This is section 7.3, proving that a quadrilateral is a parallelogram. And we see that we have two theorems on screen. Our first is Theorem 7.7. It is titled the Parallelogram Opposite Side Converse, and it states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Notice that we see that the opposite sides are congruent, marked with one tick mark and two tick marks respectively. And we have an if statement. If AB is congruent to CD and BC is congruent to DA, then we can say that ABCD is a parallelogram. So knowing that, we can now say that these two sides are parallel and put parallel marks on it. And we can say the same thing is true about the other two sides and put parallel marks on it. Then we have Theorem 7.8, titled the Parallelogram Opposite Angles Converse. And it states if both pairs of opposite angles in a quadrilateral are congruent, then the quadrilateral is a parallelogram. Notice there are congruent marks on the opposite angles here. And after we've identified that A is congruent to angle C and angle B is congruent to angle D, we can conclude that this is a parallelogram, and that means we can put the parallel marks on the opposite sides. So the operative word in these titles are converse. Remember that converse switches the order of what we know and what we can conclude. So now we can apply these converse theorems, and we see the example on screen states for what values of x and y is this quadrilateral a parallelogram? Well, because the algebra is placed on the sides, we would want to set the opposite sides equal. So we can say y equals x plus 7, and we can say that x plus 9 is equal to 2x minus 1. And we see that this first equation has two variables. And the second equation has one variable. So equation 1 has x and y, equation 2 has x's and only x's. So we will solve equation 2. So x plus 9 equals 2x minus 1 becomes 10 is equal to x. And once we know that 10 is equal to x, we can take that and plug it into the x of the other equation. 10 plus 7 gives us 17, so now we know that y is equal to 17. And if we were to plug these values in, we see that if y is 17 and x is 10, we get 17 is equal to 17, meaning opposite sides are congruent. And if x is 10, we see we get 10 plus 9 is 19, and 2 times 10 is 20, but minus 1 is 19. Again, we get opposite sides congruent, and that makes this a parallelogram. Here are our next set of theorems. We have Theorem 7.9, which states that if we have opposite sides that are parallel and congruent, so with this test, we only need one pair of opposite sides in a quadrilateral, and notice that this one pair is congruent and this one pair is also parallel. So they've marked one pair of opposite sides that are congruent and parallel, and that is enough to conclude that this quadrilateral is a parallelogram. And then Theorem 7.10 states that if the diagonals of the quadrilateral bisect each other, then the quadrilateral is a parallelogram. Notice that this diagonal is cut into two equal parts with two tick marks on each half, and the other diagonal is cut into two equal parts with one tick mark on each diagonal. So what this chapter's notes is focusing on is showing that the properties of a parallelogram exist so that we can conclude that a quadrilateral is a parallelogram. And now we'll look at applying some of these other properties. They've already shown us that these two parts of the diagonal are congruent. It is up to us now to solve for x to show that Fn is congruent to Nd. So we set 5x minus 8 equal to 3x. We'll subtract 3x from both sides and add 8 to both sides. This gives us x is equal to 4. And when we plug 4 into each of these, we get Fn is equal to 5 times 4 minus 8. Fn is 20 minus 8. Fn is 12. And then when we plug x equals 4 into Nd, we see that Nd is 3 times 4. We see that Nd is equal to 12. So we've shown that these are congruent. They already gave us that the other diagonal was cut into two congruent parts. So now we can say diagonals bisect each other. Our conclusion is that CD is a parallelogram. So here's some other problems where we can apply the properties of parallelograms to show that a quadrilateral is indeed a parallelogram. So problem 1 starts with quadrilateral WXYZ. It will always benefit you to draw this out to make sure we follow the order of the vertices correctly. So WXYZ. We went in a clockwise motion around the quadrilateral. Now we can put the measurements they gave us in here. So 42 degrees at angle W, 138 at angle X, and 42 degrees at angle Y. So we see that 42 plus 138 is 180. And once again, we have 180 here. And since there are 360 degrees in a quadrilateral, we can take 360 and we can subtract the 42 plus 138 plus 42 from it, and we see that we get angle Z is equal to 138 degrees. Number 2, for what values x and y is the quadrilateral ABCD a parallelogram? Explain your reasoning. So now we can take consecutive angles and say 4y plus 2x is equal to 180. But now I have two different variables. So I might say, what if I took opposite angles and set them equal? That would give me 4y equals y plus 87. And I see there's only one variable in this equation. So let's go for this equation so that it simplifies. So I subtracted y from both sides. Now when I divide both sides by 3, I get y is 29. And now I can take the other opposite angles and set those equal to each other. 3x minus 32 equal to 2x. Once again, my equation has all the same variable. So I will subtract 2x from both sides and add 32, and we get x equals 32. And these are the measurements for x and y that will give us a parallelogram. So in this section, they're asking that we state the theorem that we can use to show that the quadrilateral is a parallelogram. Here, for number 3, we see that they're showing us opposite sides are parallel and that the same opposite side is also congruent. So for number 3, it is one pair of opposite sides is parallel and congruent. Number 4, we see that we have two pairs of opposite sides that are congruent. So we're not working with just one pair of opposite sides, we're working with both pair. So we'll say both pair of opposite sides are congruent. Number 5, we see that opposite angles are congruent. So that's our theorem that we're using for number 5. And number 6 says, for what value of x is the quadrilateral MNPQ a parallelogram? And it says to explain your reasoning. We have that the diagonal QN is cut into 2 equal parts. We need to show that the diagonal MR is 2 equal parts. So we will set its parts equal, 2x equal to 10 minus 3x. When we add 3x to both sides, we get 5x equals 10. And when we solve for x, we get x is equal to 2. So when x equals 2, then MNPQ is a parallelogram. So this is a recap of all of the properties that we were using to show that a quadrilateral is a parallelogram. You should keep this list handy to help you with the homework for this section. Here we have a coordinate plane problem, and it says show that quadrilateral ABCD is a parallelogram. They didn't specify which method to use, so I'm going to use the definition of a parallelogram. The definition says a quadrilateral with opposite sides parallel To show parallel, we use slope. Because they gave me an image, counting slope will be easy. So from A to B, I have to go up 2, and to the right, 1, 2, 3, 4, 5. So the slope of AB is equal to rise over run. And if I look for the side that I think is parallel to AB, that would be DC. So slope of DC. We see we go up 1, 2, and to the right 1, 2, 3, 4, 5. So rise over run is 2 over 5. From here, because the slopes are equal, we can say that AB is parallel to DC. And now we have to check the other set of parallel sides. So let's clear this area. And now let's compare AD. AD has 1, 2, 3 down and 1, 2, 3 to the right. So the slope of AD is -3 over 3, which is equal to -1. And now the side opposite is BC. And we see that from B we go 1, 2, 3 down and 1, 2, 3 to the right. Slope of BC is 3 down, which is -3, 3 to the right, which is +3. That gives us a -1. And we can say that AD is parallel to BC, and that's because they both have the same slope also of -1. And that's enough to show that ABCD is a parallelogram. because we showed that opposite sides were parallel. On this page, you're asked to identify which figures we can say are parallelograms and to explain. And the first one we can say is yes, opposite sides are congruent. The middle one we would say no, because these are the vertical angles around the diagonals and there's no property that addresses that. This third one across the top we would say no, because we have to show that the same pair of opposite sides is both parallel and congruent, not that one side is parallel and one side is congruent. And we can draw a counterexample here. I can draw an isosceles trapezoid. And an isosceles trapezoid will have a pair that are parallel and a different pair that are congruent. And the isosceles trapezoid also has a pair of diagonals that will have congruent vertical angles, just like we saw in example 2. So this is known as a counterexample. And it is a counterexample to both of these. So in the bottom row, the first one, we would say yes. Diagonals bisect each other. And the second one across the bottom, we would say yes. We have one pair of sides, both parallel and congruent. And for the last one, we would say yes, opposite angles are congruent, or you could say consecutive angles are supplementary. So this is the end of our lecture. Watch it again, take notes, pause it, try the problems on your own, and then do the assignment.